All right, there we go. We would look to FOIL first, and then what did we end yesterday talking about? What would happen to these middle terms? They'd be gonzo, and then we would end up, and I'm not going to keep going because that's not the focus of today, but having that I squared, it'd be a -1. We'd be able to simplify, get it down to one number, all that kind of stuff. But what we ended talking about yesterday is that if we look at what is going on here, 3i plus 4 and 3i minus 4, I asked what was funny about those, and you guys said that they were imaginary numbers and all kinds of things that weren't quite the right answer. But then somebody said that they're the same thing except one's positive and one is negative. And that really is what a conjugate is, where we have the same thing or the same term, but we have one that is positive and one that is negative. And we're going to look at two different types of conjugates today. One of them is just like what we looked at in that example with imaginary numbers. Now, if we have any type of imaginary number, even if it's a plus our imaginary number, then a 0 is not only the positive version, but also the negative version. You know how we talked about yesterday, imaginary numbers come in pairs? That anytime we looked at, like when we looked at a graph that looked like this, I think it was the first one, and it said it was a degree of 5. Well, we could see one real solution, but then we knew that there had to be 4 imaginary because it was a degree of 5. And we talked about how the number 4 for our imaginary numbers made sense because imaginary numbers, our rule for yesterday was just that imaginary numbers come in pairs. So we either had 0 imaginary, 2, 4, 6, 8, whatever, but we could not have 1 imaginary solution or 3 imaginary solutions or something like that. Now, they're just extending that idea to say, hey, even if we have something that is like 3 plus 7i, this is still an imaginary solution. So not only is 3 plus 7i one of our solutions, but 3 minus 7i is also one of our solutions. The conjugate is one of our solutions. Are we okay with that? That fits with what we've been talking about. It just expands it a little bit. Now, not only do imaginary numbers come in pairs, but also square roots come in pairs. So if we have something like it says, let f, or let our function be a polynomial function with rational coefficients, so just regular numbers. And let a and b be rational numbers such that b is irrational, or the square root of b is irrational. That would be something like square root of 2, square root of 3, square root of 5 would be an irrational square root. If a plus square root of b is a 0 of f, then also a minus square root of b is a 0 of f. So you can see they're the same thing except with different signs. They are conjugates of each other. And like it says, if a plus square root of b is one of our zeros, then also a minus square root of b is one of our zeros. Why does this make a little bit more sense based on what we've talked about the last couple chapters? Why would this make a little bit of sense, actually, based on how we find zeros? What have we used that has the plus and minus and a square root and a number in front? Yeah, Raiden? Yeah, if you think of our quadratic formula. Oh, I wish I had the song ready to go. Oh, whoa. That's why I need the song. Opposite of b, just my square root of b squared minus 4ac over 2a, right? So really both these things, but I think you see it more with the square root, both these things do make sense that if we have the positive version, we also need the negative, or if we have the negative, we also need the positive. Because if we think about our quadratic formula and how we find those zeros, I mean, really it could come down to something, or it does come down to something in this form if we can't take the square root of whatever b is. It could come down to, I mean, we saw ones that were like 3 plus or minus the square root of 7. Sometimes maybe that was over 2, but the point is that because of our quadratic formula, this should check out that we have the positive and the negative version when it comes to square roots, and even when it comes to irrational, or when it comes to imaginary numbers. Are we good with that so far? Okay. Here is how, am I going to do your homework for you today too? Dang it. All right. Here is how that plays out into like an actual problem.
Oh, paper.
Real paper. I did think it was kind of funny that we would have to do the half sheet assignment on a full sheet virtually, but I'm guessing you guys like the actual real half sheet a little bit better. Sorry, Grace, thank you. Oh, already gave it to you guys? Oh, you did. Now it looks like I'm doing number 4 for you. Is that the hardest one on there?
Yep. Cool. I'm not complaining.
Oh, it is. I'm getting soft in my old age. All right.
Your old age is like 20.
Yeah. I was 22 last year. Didn't mess around. Now that I'm.
Be a bitter old man by 27.
Yeah, pretty much. All right, let me get this problem written down here. Number 4.
There's too many numbers.
3, 4 plus 2i. Oh, this is why I did it, because it has imaginary numbers and square roots. You're welcome.
That's great.
I'm not complaining.
Now, the half sheet says in the directions, write a polynomial of the function f of least degree. I spit a little bit when I said that. That has rational coefficients and a leading coefficient of 1 and the given zeros. Pretty much all that means is they are telling us that these numbers are the solutions to some equation. We need to write the equation. Well, if I told you, let's backtrack for a second. If I told you that just the numbers -4 and 5 were the solutions to some polynomial, how would we be able to set up an equation for that? What would our equation be? Yeah. Right, x plus 4, x minus 5. Now, that's all we're looking to do when we write the large equation for these. Good job, Alton. Now, if we look at the number 3, x, it's a positive 3, so x minus 3. Thank you. Look, when we write this, we need one that is x minus 4 plus 2i, x minus 4 minus 2i. So our default, here's what I mean, our default operation is subtraction for both, but when we look inside our parentheses, that's where the conjugate is. Because our plus for one and our minus for another, which makes way more sense looking at our definition. So then the same would be with the 1 plus root 7. Yep. We would have x minus 1 plus root 7, and then x minus 1 minus root 7. Again, our default operation is subtraction. If you remember back to, where did it go? Nope, not there. Here, x minus k, x minus k. So our default in the middle is subtraction, but then we need, come on, keep going. Whoop, there it is. But then our conjugate needs to be on the inside of these parentheses. Yes.
So then with like 3i,
Which one? So then we just have positive 3i and negative 3i, so that's fine. But then we do this one, we do 2 minus I and 2 plus I.
okay.
There's 3 together. You need to decide what variable you want to get rid of.
It's just the angle.
Hey, you guys staying on that?
Yes, look, it's all the outside.
put down Pascal's triangle.
I know.
Impressive. That was just FYI for fun.
The funsies?
Did I not give you guys paper?
Okay. I know that you didn't know I was taking notes like that, but that was really useful.
So we're just not doing 4.7.
Well, you want to know what 4.7 is? You guys are going to be really happy that we're not doing it. 4.7 is we take all these polynomials, and then remember the vertical stretches and shrinks and left and right?
Yeah,
We do that with polynomials. So it would be a really good review for exam stuff, but
Wait, so
unfortunately.
What is that? I'm sorry. Oh, I didn't see it.
Well,
Wait, so like, are we gonna learn it?
no. I just put it in to the slides because that was on my. Yeah, you don't need that.
It's so. I'm just gonna put it on a different piece of paper. It's okay.
You can if you want to. Yes?
I'm not gonna.
I think I've been screen recording the whole time. Yeah. So for anyone the one person who might actually watch this someday, I will cut that out and then it'll look really good.
Yeah, I don't think I'm
Yeah. I know. All right. So come on, give me a new slide. Whoa. New slide. Why doesn't it give me? It usually gives me another page. How do I give me another page?
It's just telling me that we're done.
Yeah.
Document scan. I literally just want another page right here. The stupid update. What if I want to go to page 18? Doesn't let me. Well, this update is ruining. Oh, maybe this one. Okay, I'll just get out of here. This will work. All right, let's look at that 4.8. Now we are taking our equations, or they give us an equation. Now we're going to graph it, which is what we did a little bit yesterday, and you probably worked on a couple of those today, but we're going to be a little bit more picky with our graphs. So if we look at, let's see, which one do we want to do together? How about number 1? They say f of x equals x plus 2 squared times x minus 3. So if we're looking at our graph, we know that there's something going on at negative 2. We also know there's something going on at positive 3. Right? We're good with that? Okay. Now, how are we supposed to know what's going on with our end behavior? Like, how do we know if we're coming in from this angle and going through, or this angle? Yeah, I mean, you could technically FOIL it all out and see what your degree is and then match it to one of your graphs on your note sheet like we did yesterday. But we want to just use our calculator. So throw that into your y equals. Oh, I need to do it too because I'm going to show you something. Yeah.
Did we not do it right? Something. We're all right.
Start back in a couple minutes.
Gonna say something like y is allowing.
Yeah. I was wrong the whole time.
Why?
Y actually lies, X doesn't. Whoops, I mixed it up, sorry. Yeah, that would be rough. So when you look at your graph, it should look something like this. Yeah? So it's easy to see, I mean, that we're coming from here. And, well, we're going to stop there for a second. Now, what we want to work towards is being a little bit more picky about graphing these local mins and local maxes. Now, we can't see it because it goes out of at least my picture, but what can we do to make it so we can see the whole graph? Yeah, we need to change our window. So we hit window, and we probably want to go negative 20, 20, 20, and then make our scale 2. So let me type that in, then I'll show you. 20, scale 2, negative 20, positive 20, scale 2. So this is what I just put in to see if this would work. Negative 20, positive 20 with a scale of 2, negative 20, positive 20 with a scale of 2. So go ahead and change your window so we can see the whole graph.
I just changed all over.
Cool. Andrew, where are your calculators?
He did.
No, you need to be doing this on your calculator.
But where?
We need to find out where the
Yeah, so now when we graph them, where we cross the x-axis are important points that we need on our graph. But we also are going to need to have those local mins and local maxes that we talked about yesterday. Now, if you can go to your table and find this, that would be awesome. But some of them are going to be a little bit messy, so we are going to learn a new thing on our calculator. If you hit second trace, like we've done a bunch of times, we've used the 0 before. We also have used intersect, but now we have this min and max. Now we need to find a local minimum here. So we're going to hit second calc, and we need number 3 because we want a minimum. Here's number 3. There we go. Now, our spider comes back on our screen, and we are doing left bound, right bound, guess again. So we're trying to find this point right here, so we need to go just left of this point, hit enter, then go just right of this point, hit enter, and then give our best guess, and hit enter. 1.3 and negative 18.5. So when we are now graphing these, 1.3 would be a little after 1, and 18, 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. So 1.3 here. We need to be a little bit more picky now with how we graph these. I think it also asks you, well, it doesn't on the first set of directions, but it should have you label these. So we have negative 2, 0. We have 1.3, negative 18.5, and then here we have 3, 0. So for the first two on that 4.8, you'll do exactly what we did right here. Punch those in your calculator, label the important points, meaning our intercepts and our any min or max. And then on 3 and 4, you'll need to graph it, and then also talk about where it's increasing, decreasing, then above or below the x-axis. So not a big change from what we've been doing. I mean, really, we've been graphing things like this since yesterday, but now we're just adding that we need to find the mins and the maxes. Can we do that? No. What part of that can we not do? And don't say all of it. Not allowed. Oh, okay. That's fine then. But that's what we're looking at. So the rest of the 3 problems on that page, and then the other stuff that we've been working on would be what we want cleaned up for tomorrow so that we can review chapter 4 tomorrow.